talk about chapter 4, which is about torque. So when we are talking about torque, we are trying to understand how does forces create rotation. So from here, we can see rotation of the store or spinning of the ball. So in general, when we are talking about torque, we are talking about action that causes object to rotate. And be careful that the torque is not the same thing as a force. Therefore, for rotational motion, the torque is what is most directly related to the motion, not the force. So now, when we are talking about rotation or about torque, we are talking about rotation. And when we are talking about force only, we are talking about translational motion from point to another point along either x-axis or y-axis. Now, in general, torque is a physical quantity that allows us to measure the tendency of a force to rotate an object about some axis. As you can see here, we have a rigid object, which is along x-axis, or sometimes can be along y-axis. This object has the following parameters. The first one, the object is fixed at a certain point, which is a pivot. Second parameter, the force and acting at a certain distance from this point to the fixed point. Third parameter, which is the lever arm. And pay attention that the force and the lever arm, both of them are vectors. Now, to calculate the torque, in general, torque is R cross F. This leads us to cross product, but in our lecture, we do not care about cross product. Therefore, we are going to use the following formula, which is the magnitude of the torque, where torque, the magnitude of torque equals R times F times sine theta. Now, as I mentioned before, torque will, when we are talking about torque, we are talking about rotation. Therefore, we have to have a magnitude and direction. So the direction of the torque, either counterclockwise or clockwise. Now, to determine the direction of the torque, we are going to use the right hand rule as the following. Now, in the right hand rule, you have two parameters, the direction of R and the direction of force. Now, in general, in your hand rule, you have your fingers and your thumb. So let me take this example. Now, the direction of R is all the way to the right, and the direction of the force all the way up or vertical. How to use the right hand rule? In general, now to use the hand right rule, I suggest to you to do the following. Align your fingers at the same direction to the lever arm, which means your fingers should be all the way to the right. Then curl them or curl your fingers at the same or toward the force. Clearly, you can see your thumb is out of the page or counterclockwise. Second case, as you can see here, do the same procedure. Align your fingers at the same direction to the lever arm, which means your fingers should be to the right. But now to curl your fingers toward the force, you have to flip your right hand downward. So clearly you can see your thumb all the way down or into the page, which means clockwise. So from here, sorry, from here you can see the direction of the rotation or the direction of the torque, either counterclockwise, which is positive or out of the page, or clockwise, which is negative or into the page. So in general, you have to pay attention to the following when you are going to calculate the torque. First of all, the torque has a unit of Newton times meter or meters times Newton. Second, if R equals 0, like if we put the force exactly at the fixed point or at the pivot, that means your lever arm equals 0. So if R equals 0, then the torque equals 0. 3, if the force is parallel to R, that means angle theta is 0. So sine 0 equals 0. So this will give you torque equals 0. Number 4, if the rotation is counterclockwise, that means your torque is positive. And if the rotation clockwise, that means your torque is negative. Okay, when we are talking about torque, we are talking about nature vector of the torque. And please pay attention when you are going to calculate the torque about a certain point, you have to have the whole forces and their action as a torque. Now, in this example, we have a rigid object fixed about certain point. Let us call it P or O, and we have like 5 forces acting on this object. Now, the total torque around point O or point P or around this fixed point, it will be torque from F1 plus torque from F2 plus torque from F3 plus torque from F4 plus torque from F5. And pay attention, torque from F4 and torque from F5 canceled out. Why? Because F4 is parallel to the lever arm, which means the angle theta is 0 and sine 0 equals 0. And torque from F5 is 0 too because the lever arm is 0. Okay. Sorry. So the following example, find the total torque applied by the given forces around the pivot, around this point, where F1, F2, and F3, all of them have the same magnitude, which is 100 Newton, and the total length is 3 meter, and the distance from F2 to the pivot is 1 meter. Okay, here we are talking about the nature vector of the torque. So that means we are going to do the following. First of all, to do the torque, this will be coming from torque due the first force, torque due the second force, and torque due the third force. Now, the torque from the first force, as you can see here, the distance from the action or the action point to the pivot is 3 meters times F1, which is clearly here perpendicular, so sine 90. Now, R1 times F1, but we have to know the direction of the torque. Is it counterclockwise or clockwise? As I mentioned before, all what you have to do is the following. Directed or align your fingers to the right, as you can see here. Then curl your fingers toward the force. So you will see your thumb all the way into the page. That's why here torque from F1 is negative. Now for F3, it's clearly the torque from the third force here is zero because the lever arm length or distance equals zero. So now we have to calculate the torque from or due to the second force, but be careful. Here, second force or F2 is not perpendicular. So what you have to do is resolve F2 into two components, one along x-axis and one along y-axis, and clearly the one along x-axis is parallel to the lever arm. This will give you zero. So the force perpendicular to this will be F2 along Y or F2 sine 37. So you will have R2 F2 sine 37, and the direction of the torque from or due F2 will be counterclockwise, so it's going to be positive. Now you have torque from F1, torque from F2, and torque from F3. Go back to the original formula here. So 60 plus minus 300 will be minus 240 Newton per, or I'm sorry, minus 240 Newton meters, or 240 Newton meters clockwise, or 240 Newton meters into the page. Okay, another example. So in the figure shown below, find the net torque acting on the rod about the right end if the rod is massless and F1 equals 60 newtons, F2 100 newtons, and F3 40 newtons. Okay, let me take this example on details. In general, to calculate the torque, as I mentioned before, I have the following steps. First of all, the torque, I have the following steps. First of all, determine the point that we are going to calculate with respect to it, which is here at the right end, which means here. So our pivot will be at this point. Second point or second step, the torque at this point is coming from torque due F1 plus torque due F2 plus torque due F3, as you can see in this formula. Now, torque from F1, it's obviously equal zero because the distance here, or the lever arm distance or length, equals zero. So I have now to calculate the torque from F2 and torque from F3. As you can see here, torque from F1 equals zero, and I mentioned the reason because the lever arm distance or length equals zero. Second, the second torque or the torque due F2, as you can see here, F2 rotates this object about the pivot counterclockwise, so it's going to be positive. This is number one. Number two, torque, this force here, F2, is perpendicular to R2, so it's going to be R2 times F2 sine theta 2, whereas the angle here is 90 because F2 and R2 are both of them perpendicular to each other, and the torque is positive because it's counterclockwise. Therefore, the torque is 100 newtons times meter. The third force, as you can see here, it will be R3 times F3 times sine theta 3, where theta 3 here is 90 because R3 and F3, both of them are perpendicular to each other. So R3 is 3 meters, F3 is given, which is 40 Newton, and the direction of rotation here is clockwise, as you can see. Therefore, we can go back to the original formula where the net torque equals to torque 1 plus torque 2 plus torque 3. Add them together, you will get 20 newtons times meter clockwise or out of the page or negative. Example number 4. In this example, calculate the net torque or the total torque at the point A. Okay, this is the fixed point or our pivot. Now, clearly, you can see that the force here is not perpendicular or parallel to the lever arm. Therefore, we need to resolve this force into two components, X component and Y component, as you can see here. So we have Fx along X-axis and Fy along Y-axis. Now, the total torque about point A or the net torque at the point A or at the pivot will be torque coming or torque due Fx plus torque due Fy. But clearly, torque due Fx equals 0 because this force is parallel to the lever arm vector, and the angle here is 0, sine 0 equals 0. So the rest or the left will be only the torque due the perpendicular force, which is 25 sine 54. Now, torque due Fx equals 0, but torque due Fy will be the magnitude of Fy, which is 20.2 times 1.6, and the torque here or the rotation here is counterclockwise. So, oh, sorry, here this should be Fy instead of Fx. So please replace it by Fy and this by Fy. Another example, so which is example 6. As you can see here, find the torque or the net torque or the total torque about point at the midpoint or at the middle. Okay, in the previous examples, all of them, the lever arm vector at the x-axis. So let me flip it and take it about y-axis. So the net torque about this point is coming from torque due F1 plus torque due F2 plus torque due F3, as you can see here. But torque due F2 is 0. Why? Because the lever arm distance is along y-axis, and F2 is along y-axis too. So the angle between the lever arm here and F2 equals 0, and sine 0 equals 0. Now, so torque due F2 cancel out. The left is due F1 and F3. So the torque along or the torque due F1, since F1 is already perpendicular to R, it will be F1 times the distance, which is times 3. So it will be 30 newtons. But here you can see the rotation or the direction of the torque due F1 all the way clockwise. So that's why it's negative. For torque coming from F3 or due F3, this one is same as the previous example. Since the force is not parallel or perpendicular, and we have an angle, so you have to resolve F3 into two components, one along y-axis, which is parallel to R, so this will give you 0 torque, and one perpendicular to R, which is along x-axis, and this will give you R3, F3 sine theta, sine 37, and the rotation is clockwise, that's why it's negative. So now we have torque from F1 plus torque from or due F2 plus torque due F3. This will give you minus 42 newtons times meter, or 42 as a magnitude and clockwise as a direction, or 42 as a magnitude, and into the page as a direction. Okay, let's go to the following example, or the second or another example. Now, if the net torque about point O, this is point O, is 0, what is the length L? Okay, let us take this one step by step. First of all, determine your forces and write the net torque about this point. So I have a torque from F1 plus torque from 3F from plus torque from 2F, as you can see here. But from the question, the net torque equals 0. Now, the torque from F is the as you can see here, it's already perpendicular. So it will be the distance from here to point O, which is 2 meters, times F, or the magnitude of the force, which is F. And be careful here, F is a known 2. Now, it will be 2 times 2F times F, I'm sorry, 2 times F, which is 2F. And the direction of the force due to this force will be clockwise. That's why it's negative. Torque coming from 3F, it will be the distance from here to here, which is L, times the magnitude of the force, which is 3F. So the torque will be 3FL. And be careful, the direction of this force is all the way up, but the direction of the torque, it will be counterclockwise, which means it's positive. Now, the last force, which is 2F, so torque to 2F, since this force has an angle, so we have to resolve this force into two components, one along x-axis, and it will take sine 60, and the second one along y-axis, which is cosine 60. So 2F times cosine 60 times the distance, which is 0.5, this will give you plus F, and the plus sign due to positive rotation or counterclockwise rotation. Okay, so we have the torque from F, torque from 3F, and torque from 2F. Now, take all of them and go back to this main equation or formula. Minus 2F plus 3FL plus F. You will find L equal 1/3, or 1/3 meter. So doesn't matter if the force here is unknown, because by the end F with F cancel out.